Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will discuss about SG iron, and before going in detail of the SG iron, let us discuss what are the properties of SG iron. Now, first of all, SG iron is standing for spheroidal graphite iron. It is also known as nodular graphite iron or also known as ductile iron. Now, in this SG iron, it contains graphite in the form of spheroids instead of flakes, and matrix of grey cast iron and SG iron is same as we can see in the figure over here. Here we are having grey cast iron in which the carbon is present in the form of flecks, of different dispersed in the matrix of iron. While in case of ductile iron or SG iron, these flakes has formed is available as spheroids dispersed in the whole matrix. Matrix is the same as that of SG iron. Now, therefore, the properties due to this spheroids get changed. It is having low melting point, good fluidity, it is castable, and excellent machinability with good wear resistance, high strength, toughness, ductility, hot workability. While in case of grey cast iron, the ductility is almost absent, while in case of SG iron, it is having good ductility and therefore and also hot workability can be done and heat treatment be done, hardenable and enhanced properties by doing heat treatment. And therefore, control in the properties can be, as the matrix can be controlled by base composition. We can change the base composition of the matrix by alloying and by doing foundry practice, and also we can go for heat treatment, which is not possible in grey cast iron. Therefore, the maximum tensile strength can be up to 415 megapascal with 25% elongation. You can see the ductility, and the maximum tensile strength can be up to 1030 megapascal with 4% elongation. Now, therefore, due to that, those properties, application has got enhanced. It can be used for motors, vehicles and parts, farm machineries and equipment, plate works, boiler shop, and paper industry machineries, IC engines, metalworking machineries, pumps and compressors, construction machineries, motor and generators, power station equipment, ductile iron pipe, etc. can be obtained. Now, solidification. Before going into detail of the properties of SG iron, first of all, let us see what is the solidification process of grey cast iron and that of the SG iron, so that we can obtain SG iron. Now, we know that solidification of grey cast iron depends upon, involves formation of flake graphite in austenite eutectic. Eutectic solidified conventionally with austenite, and graphite is in contact with liquid eutectic liquid. Now, solidification proceeds by the growth of cells of austenite and flakes of graphite. Grey cast iron is essentially iron carbon silicon alloy. Now, the eutectic solidify over the temperature range of about 33 degrees centigrade. Further cooling causes rejection of carbon from the solid austenite that precipitate on the pre-existing graphite flakes. Now the process continues till eutectic temperature is attained, and then further solidification causes the flakes of carbon is being liberated. But in case of solidification of S.G iron, if we go into the base chemistry of grey cast iron and S.G iron is same, as we know the matrix is same, but mode of solidification is different. Now, in case of solidification of sporadic graphite eutectic in S.G iron, it starts at a temperature above than that of the flake graphite eutectic for similar carbon content, that of grey cast iron and equivalent S.G iron. Now, therefore, in case of graphite sporadic is enveloped by a shell of austenite, thus only one phase austenite, not the flakes, austenite is in contact of the eutectic liquid. This type of solidification is termed as eutectic. Now each unit cell or each shell contains graphite sporide and austenite shell, surrounding austenite shell. Now the carbon in the unit diffuse through the shell into the sporide to row, and the process is slower. The diffusion process is slower than grey cast iron eutectic solidification. The eutectic freezing range is extended to about 67 degrees centigrade. In case of grey cast iron, it is only 33, small range, 33 degrees centigrade. Here it is almost double, 67 degrees centigrade, but it is at higher temperature. The liquid present over a wide range and to a lower temperature. Now there were no nucleation occurs. Once growth of new eutectic starts, then there is no nucleation. Number of graphite strikes is determined at the early stage of solidification. Subsequent swelling causes graphite precipitation on the existing spheroids at temperature down to eutectic range. Now stress is to be given to obtain adequate number of spheroids. Otherwise, if the number of the spheroid is low, there is a chance to diffuse an inadequate number of sites of flake graphite or iron carbide. Now, if this happens, now flake graphite sites occurs or iron carbide occurs, then this will deteriorate the quality of the alloy. Now, therefore, what is the role of magnesium? The most commonly accepted method to obtain this graphite, spiral graphite, are other elements other than magnesium are cerium, calcium, yttrium. Now, first, magnesium serves as deoxidizer. It also desulfurizer of the molten metal. It desulfurizes if the sulfur content is more, then first of all it desulfurizes the molten metal, and the remaining substantial amount of magnesium is consumed to form oxides and sulfides of magnesium. Therefore, in second, after the desulfurization, then this remaining magnesium promotes the formation of spheroids. Finally, magnesium prevents formation of flake graphite. Therefore, magnesium has got three roles. One is to deoxidize as a deoxidizer or desulfurizer. Secondly, promotes the formation of spheroids. Not only this, prevent. Thirdly, prevents the formation of flake graphite and promotes not and furthermore it promotes the growth of spheroids. Generally, 0.05% residual magnesium necessary to form spheroids. Now, this is all about S.G iron. Now, therefore, we will go in further detail in S.G iron part 2. Thank you.